Why does serverless architecture have cold starts? Imagine your code is like a car that only starts when you press the ignition. In serverless architecture, this is exactly what happens when a function is called after a pause. Instead of keeping the engine running all the time, the platform only gets it ready when needed. This approach saves money and resources but introduces a delay called a cold start. Serverless platforms like Amazon Web Services Lambda, Microsoft Azure Functions, or Google Cloud Functions do not keep your code running constantly. Instead, they create a new temporary container or environment each time your function runs after being idle. This container includes the operating system, the programming language runtime such as Python or Java, and all the libraries your code depends on. Setting up this environment takes time, which causes the delay known as a cold start. Cold starts happen mainly in a few situations. First, when you deploy a new version of your code, the platform needs to set up a fresh environment. Second, if your function has scaled down to 0 because no requests came in for a while, it will need to start from scratch again. Third, after a period of inactivity, the platform might terminate the environment to save resources, so the next call has to start anew. Lastly, if the cloud provider moves your function to a different server or reallocates resources, a cold start can occur. The time it takes for a cold start depends on several factors. The programming language used matters because some languages like Python start faster than Java or Net. The size of your code package also plays a role. Larger packages take longer to load. Complex dependencies or external connections, like databases or third-party services, can add to the delay during startup. For example, lightweight languages like Python often have cold start times of just a few hundred milliseconds, while Java might take a second or more. From a backend development point of view, especially when working with APIs, databases, or server-side logic, cold starts can cause a slight delay in response times. This can be noticeable in applications that need instant reactions, like real-time data processing or user interactions. But most requests are served quickly once the environment is warm. To reduce cold start impact, developers use strategies like keeping functions warm by periodically invoking them, which prevents the environment from shutting down. Choosing faster runtimes, minimizing the size of deployment packages, and optimizing initialization code can also help. Some cloud providers offer features like provision concurrency, which keeps a set number of environments ready at all times, eliminating cold starts altogether. In the end, cold starts are a natural part of serverless architecture because of its on-demand, cost-efficient model. They happen because the platform needs to prepare a fresh environment before your code can run. While they introduce a small delay, they also enable the scalability and flexibility that make serverless so appealing for modern backend development.